May I request our speakers to come on the dais, please, Mr. S.C. Mehrotra and Mr. John Hardy. Mr. S.C. Mehrotra has over 42 years of experience in structural design and is heading the Mehro firm. I would now request him to introduce John Hardy and begin the session.
I welcome you to this session, and I hope this is quite a different session maybe from the earlier you have been watching. And we start with our first speaker, Mr. John Hardy. I'll give you a very small brief about him. Mr. John Hardy, he's from Bali, but originally he was in Canada, and then he came to Bali in 1975, and for the last 10 years he has been using the bamboo for structures, and he has done about 60 major structures using the bamboo. And 8 years back he has started the Green School. And with this introduction, I invite John Hardy to give his presentation.
I'm really happy to be in India. I wanted to come to India in 1975, but I was afraid. And it took 10 years to get up enough, to become bold enough to actually come to India. But since then, I've been here many times, and I really think India is probably the future of the world. And I'm very happy to be here, and I hope to meet Mr. Teddy. But a few years ago, I had a guy named Ted asked me to come and speak, and I didn't meet him either. But I went to Oxford, and I made a little speech about the Green School. And I'm a very proud father of a 32-year-old, and I get on a plane tomorrow morning, and I go to Vancouver, where my daughter, who you'll meet in this talk, is addressing the TED audience for the first time. And what's happening in the background, if you can see it, is a very quick little building. This building was actually made in just 3 months. And the fastest thing that happened was the thatch on the roof. And it seemed to be because the thatchers got paid by the stick. So they got up early in the morning and they finished this building in only 3 months. And I want to show you a little bit about Bali. Bali is a beautiful place. It's one of the great paradise islands in the world. And the reason I live there, I think, is primarily because it's Hindu. There's many islands in the world, but Bali is magic. And in Bali, we have cows. They're not quite as sacred as the Indian cows, but they're very pretty. And they cut the grass. And this is a green swimming pool. You've all seen swimming pools, but this one is actually green. It's growing food, water hyacinth, for this guy, who is not a sacred pig, but he's very revered. And he lives in the garden. And this is probably what you have a lot of in India, is an honest man. And this is a story about bamboo. He's holding a bamboo shoot. It's really simple. It starts this big. There it is. Here it is 5 years later. Nothing in the world does this. And here it is shooting. It comes out of the ground like a train. In 2 months, it can be 14 meters high. And we wait 3 years before we cut them. And this is 5 days ago and 2 days ago. And you can see the 5-day picture. The bamboo's this tall, and it's growing 50 centimeters a day, and 2 days later, I couldn't even touch it. And here we are. It's long. It's a bit of a problem. Often the bamboo has to come down from the high mountains in the middle of the night to avoid the police checks. We wash them with water, and then we put them in a 14-meter bath of borax. where they sit for a day. And borax is the magic material. It's a natural salt from Salt Lake City, Turkey, and Tibet. And once the bamboo has been in there, it becomes a virtually endless supply of sustainable material for making permanent buildings. And all you have to do is plant those seedlings. We twisted it, we broke it, we tortured it, and now we know enough how to build buildings, engineer buildings, in a completely different way. People have been living in bamboo buildings since the beginning of time. And this is 1930 in Java. It's an amazing bridge built entirely out of bamboo. But all we've got left is the pictures. All the bamboo structures that have ever been built are gone. And it's because of this guy. He's eaten every bamboo structure ever made. But borax has stopped him in his tracks. And the borax doesn't kill him. He bites the bamboo, he gets diarrhea, and he goes home. I guess it's sort of like some tourists in India. So now we can build things that are permanent, and they're sustainable. I know you've been talking about sustainable for days, but this is really sustainable. It's a 22-meter-long bridge and completely built out of bamboo. It's the biggest bamboo bridge in Asia. And we can do beauty. I mean, in my country, we're born in a box, we live in a box, and then when we die, they put us in another box. And so I really, really wanted to get away from the box. So this is a double helix. It's called the Heart of School. And here's the model. It's an amazing thing, bamboo models, because you build one, and then the artisans come and they make them big. And it's built by guys like this. This guy is not a doctor professor. He doesn't work for Google. But he has all the skills he needs to turn the bamboo into beautiful buildings. And they're using ancient techniques. And this is an amazing hand-built, hand-raised building. And it looks like complete chaos. But when the scaffolding comes down, these amazing structures emerge. So the school has been getting in the way of the business, because these kids are going to school in bamboo buildings and they go, we want to build. And most young people really want to build. And my daughter put this model together, and it's completely made from bamboo and rubber bands. And then she built it with some friends. And here it is going up. Of course, it went on Instagram. And here it is finished. It was 8 meters high. And this happened in a week. It used a lot of rubber bands and a lot of bamboo, but it's not a permanent building. It's just a way to allow children to build. They all want to build. And then we moved it into an amazing structure, which is an air structure. So it was a lot of fun in there. And here it is sleeping at night when the air is out of the air structure. And the air structure escaped one night and was found the next morning in the rice fields, which caused a lot of problem with the farmers. They wanted to know why it was there, because it was, fortunately, it was right after the harvest and before the planting. So
it must look, yes? And not like in Switzerland or...
that was an amazing man in Austria speaking, and he built this thing. He has rivers in Austria, but he doesn't have 10-meter drops. He only had a 2-meter drop. And so he built this amazing turbine. And we built one at Green School. And as we were building it, some other gentlemen came out of the bushes and they said, we must build it our way. And so they spent 6 months building this. It didn't work. But the vortex, you see how it works? It fills up, and it becomes very powerful. And instead of putting the river through a little turbine, it's spinning the river. And as it spins, it creates great power. And then, because we didn't have a famous engineer on site, we had to build the structure to make the turbine. So we built it out of bamboo, and we tested it with 45-gallon drums full of water to make sure it was strong enough. And here it is, spinning. Spin. There it is, spinning. And the generator is coming from China. I wish it was coming from India. But when this thing goes on a 2-meter drop, which is about this high in a small river, it will make 14,000 watts of electricity day and night. And it's really an amazing thing. There's many, many rivers in India, many, many rivers in Indonesia with a 2-meter drop. And this is called innovation because you've got the guys that talk about micro hydro. Unfortunately, they're using a turbine that was invented in 1850. So it's really the vortex is an amazing thing. And so what's coming down the river, and what do you see in the river? I was on the beach in Mumbai a couple of weeks ago, and there's a lot of stuff coming down the river and into the ocean. It's called garbage. So we have this strainer, and one of the students at the school said, well, why don't we strain the river? So we built this very crude strainer at the outflow of the vortex. And of course, we caught a lot of stuff. We caught a lot of plastic, and we caught a lot of biomass. And of course, you know about composting. We composted the biomass, but the plastic is a problem. Plastic bags that have been in the river are very hard to recycle. But the amazing thing is that these boys came from New Zealand with a better idea. They found out a way to put really poor quality plastic into a vortex, melt it, it comes out as a loaf, and they're turning Bali's plastic bags, which are litter everywhere, into these guys. And that's another curse of the planet. Every factory that you own puts things on shipping pallets to send them to wherever you're going to send them to. And those shipping pallets are one of the biggest problems in deforestation in the world. And these shipping pallets, that shipping pallet is made out of 15 kilos of plastic bags that were going to go in the ocean and then into the river. And they're using about 4 tons a day. It's called Enviro pallets. India is ripe for it because it creates a product out of waste. And it's great to send your plastic bags to places like Japan and America. So the whole plastic thing has become like a kind of crazy thing. And these are scavengers. They're kind of high-class, overeducated scavengers. But they come in the morning to my house, and we have walking meetings. They see people walk much better when they're, talk much better when they walk. So we call it spearing garbage and talking trash. And that's how much they collected in a 2-hour walk out of the rice fields. And the Balinese are watching us. They want to be modern. They want to be consumers. They want to be Americans, Canadians in this case. So this lady is following us, but she's following us in the right direction. She figured out she could sell those bottles, so she started picking them. I met her in the field. And now these 2 young women are dressed so beautifully. And they're actually, we have a little hotel next to our house, and they are the receptionists at the hotel in beautiful Balinese gear. And you see they have their rubber gloves on because what they're doing is they're sorting the daily trash into different kinds of plastic to be sold to the recyclers. So it really is interesting when you get scavengers out of a lot of different levels of society. People start to understand the game. So we're going portable. And this is a very small building. It's just big enough to be a hotel room. It will go in a container, and we'll be eventually shipping them all over the world. And this is the bathroom behind. Innovation is just so much fun. I put some of these slides in because they're brand new. A bamboo roof is a great roof, but it only lasts about 6 or 7 years. So this one is a new innovation where we wrap the bamboo in copper, which is not 100% eco, but it's not a perfect world. And this is the heart of school. This is the building you saw being built earlier. And it's a crazy building. There's 7 kilometers of bamboo in it. The building is 8 years old. 12 years ago, none of this material existed on the planet. It was only a twinkle in the eye of the mother bamboo who lives under the ground. And so it came up. And 3 years later, we harvested it. We processed it for a year, and it's been in this building, and it will be in this building for 100 years, as long as the people that come after me fix the roof. Now, I know that there was a little problem with all your trees just before independence, but if we had have cut down trees to build the same building, they would be 60 years old, and we'd have to wait another 60 years for more. So kids are graduating at Green School, and it's really cool when kids graduate. I mean, they get to go to an auditorium like this and hope there isn't an earthquake and hear a lot of smart people talk to them. Our kids said, no, we're not going to an auditorium. In fact, we don't have a proper concrete auditorium. And they built this structure. They made this drawing. These are high school kids. And they put it up. They brought fresh bamboo, 18-meter bamboo from the forest. They put it up. They sheathed it with, you know what these are? These are palm leaves. And they created a structure for 350 people to graduate in, for 350 people to come and see the graduation. And you have to tell me who this lady is, because I'm dyslexic and I can never remember her name. She deals with chimpanzees. She has a program called Roots and Shoots. What's her name? Jane Goodall, yes, yes. She came and spoke to the kids last year at graduation. I mean, where do you go after Jane Goodall is there in a structure you built yourself? It was an amazing experience. And she was followed recently with another guy who's, you may recognize. This one's harder to recognize. He runs a big organization in New York. I think they call it the United Nations. And he came with 1,000 of his best friends, and they all had guns. The school was closed down for 2 days. There were 1,000 troops around the school. There were snipers in the trees. And he was great. He spoke about the school for 15 minutes before he did the tour. And he really was well briefed because he knew all about the school. So right in the school, there's a place called Bali starlings. And Bali starlings are the #1 cage bird in Bali. And they're all gone. There were 3 left in the wild. And Ban Ki-moon and his wife, Mrs. Moon, released 2 Bali starlings. But that's when the scandal started, and it almost became an international incident. Jane Goodall's starling was in a tree nearby, and she took a fancy to Ban Ki-moon's starling, and they moved in together. And it was starting to be news that there was this union going on in the tree. Unfortunately, they were captured by a poacher, and now they're in a cage together forever in Jakarta. So Green School is a lot of fun. This is Mr. Moon speaking to one of the scholarship students. Green School, just to tell you a little bit more about it, it's got kids from 45 countries. We have kids from India. And this is one of our scholarship kids. We have a plan to have 20% of the kids in the school from local village kids. It's really, it's amazing to see these kids grow in a green environment. So you've got green education in India. You probably even have a green curriculum, and they have one in Canada, and they have one everywhere. And Green School is providing a green education for these kids. But the thing that it's really doing, and the thing that makes the difference, is they're living green. They're living in a place powered by water. They're living in a solar place. They're living in a bamboo campus. They're growing food around the buildings. And it's different than being talked to That's why I show pictures, because I don't really believe in talking. And local is so important. This is an ancient, huge bamboo gamelan that is used in Bali. So we built one at the school rather than having a marching band like the English. That's what happens when you go local. They're just learning. But in a year, they will be amazing musicians. So a lot of people are talking about solar panels. I was very lucky. I was in the parking lot of Green School, and this guy named Eric Scoto, who owns one of the most amazing solar companies in the world, came and said, "Nice school." And I said, "I'm glad you like the school. What do you do?" He said, "I make windmills." Windmills are no use in Bali because we really don't have any wind. He sent us 108 solar panels, and he sent us an engineered drawing for a giant rack, which you saw a lot of today. And I said, "I really want to have solar power, but I'm not going to put this giant, ugly rack in Green School." So we mounted the bamboo. We mounted the solar panels on bamboo and spread them along the terrace. And we didn't stop there. We wanted to make use of that land, because land use is a story. Underneath is a chicken farm. So we have organic chickens under the solar panels. And then came the drawings for the battery unit. And everyone's worried about the battery unit because batteries are dangerous. So we put them in a curve in the garden. We installed them. We covered them with a tarpaulin. And then we built a bamboo building around them. And this is the prettiest little battery house ever built. And it has yet to burn down. But this is what supplies the Green School power. I have a secret weapon. This is the woman I was talking about. This is my daughter, Alora. And she's going to be on that TED stage about a week from now, and I'm going to be there and see her. And it's going to be an amazing moment for me. She was working in New York. She was successful. She had 2 handbags that she didn't know what to do with. She had a nice little apartment. And she came to Green School, and she said, "Dad, those people in New York have no interest in green." So she came home, and as a liberal arts graduate, a fine arts graduate, she started a bamboo company, and she's doing really well. So how do you make a building? You get design CAD, and you steal some of this and some of that, and you jam it together, and you got a building. Well, these guys are still using pencils. And then they build bamboo models like this guy from the drawings. And these bamboo models are actually what the structure will be. And then they test them. And this video isn't working, but what he actually does in this video is he hammers on the bamboo model to see if it's strong enough. Then they take it to the engineers. They actually measure every bamboo in the structure. They put it in this madness, which is design CAD, and they send it to the engineers. And after the engineers have seen it, we then build it. We give it back to these guys. And they actually take these models and turn them into, just like magic, buildings. 3 months. They go up so fast. The roof is on in 6 months. And the whole thing is constantly looked over by guys, really smart guys with hats. They're watching, the artisans are the ones that are really doing it, but they sit and watch and talk and discuss, but we have to have them there. And some of the tools are really small. In the world of industrialized tools, this is a really early one, and this is one of the biggest tools that we use in the building. And it's one of the few building sites where you have to take off your shoes to go on the site. Because when you're climbing on the bamboo structure, you don't want to have slippery shoes on. So it's a barefoot building site. And the foundations are like archaeological excavations. We take the dirt away. We touch the land as little as possible. No bulldozers, no graders. And this is what holds up a bamboo building. Concrete, it's not a perfect world, going way down with steel in it. The steel comes up through the stones, which protect the feet. And then there's a little bit of concrete inside the bamboo, about this much. But these buildings are tall, and they soar, and you can do things with them that are just amazing. The structure was almost complete, and we took this photo. The tree that had been on the site was still putting out leaves. I mean, when was the last time any living thing survived in a construction site? This is inside. This is on the 4th floor. This is what's holding up the building. This is the central core tower that holds up the building. It's open air living. We look after air conditioning, don't worry, but it also doesn't get as hot as it gets here. We're on 8 degrees off the equator. And we had a big challenge. The woman wanted a TV room, and we have this beautiful flowing structure. And the TV room, and how are we going to put a box in the middle of the flowing structure? So we built a basket, and she loves it. It's her basket TV room. And the bedrooms have real air conditioning, but actually we did a trick. When you air condition a bedroom, you're air conditioning how many meters? Dozens of meters. We built an air-conditioned bed, and you see the 2 bamboo here? There's an underfloor aircon unit. The cold air comes up and dumps on top of you as you sleep, and you're surrounded by a mosquito net. So the only thing you have to air condition is the bed, which saves a lot of energy.
How many minutes more you want?
How many have I had?
You have already exhausted, but doesn't matter. It's very interesting. You can tell.
They gave me 30 minutes, so I don't know where I am.
You take another 10 minutes?
10 minutes. So this is a full-scale drawing of a piece that's being worked on, and here it is finished. The furniture is all bespoke. It's handmade. This is it being made out of bamboo, and here it is sitting beside the pool. And this is a tower on its side leading into this house. And this is one of the houses that's appearing at TED in Vancouver next week. It's actually built for an overseas Indian client from Montreal. It's the most amazing house that I've ever seen. It's 6 stories, and it's made completely of bamboo. And so swimming pools, it's a problem, swimming pools. Concrete, steel, pollution. The engineers wouldn't even talk about it, so we built this. And it was beautiful. And we reinforced it, and the boys tested it by jumping in it. And it was finished, and it was beautiful. And I took a picture of the site just yesterday. There it is. It's gone. Complete and total failure. So we keep trying. It's now a cement pool. So we're building everything from homes to hotels. This is a chocolate factory. And this is a very important structure. This is an ATM. We needed an ATM at the school. We built it out of bamboo. And the bank sent a big cement truck to lay a big slab. We put it on a rock, put it to a rock. And all this is not being done by boys from California or girls from Australia. It's being done by local kids. Their mothers think they're mad because they're building bamboo. They got that education, and they should be in Jakarta building concrete, and they're not. And it's becoming a revolution. The whole area is turning into bamboo. And some of the buildings are world class. This building was actually moved. A man came from South America, and he said, "John, let's build a car." And no one had ever built a real bamboo car, so he bent this piece of steel. He then clamped bamboo to it, and here it is. It's a 2-seater Mobius strip. He's building it in 3 models, and this is it. It's going to start out as a golf cart because the golf guys have all that money. And there's only 3 kinds of golf cart. Maybe you have one in India that's nice, but they're kind of unsustainable and ugly and then very ugly. So this is the future of golf carting. My son Oren recently graduated from a liberal arts degree in America, and he wanted to stay in America, and he said, why didn't you make me take something where I could get a job? He couldn't get a job, so he's a Canadian, so they threw him out. And I said, son, and you know fathers really are well heard by sons. Son, don't get a job, make jobs. Make jobs that are good for the earth. I mean, easy for me to say. He has. He did. He came home. This is aquaponics, and this is totally amazing. It's a windshield structure. It's a closed system with fish and plants. The fish poo in the water goes up into the beds, the nitrates become nitrates, the vegetables grow, the fish are happy. Every 6 months we eat the fish and we eat the vegetables all day long. And it's completely built out of bamboo. He did something else, which you can do here. It's called a parking farm. He took the parking lot and he built a trellis over the whole parking lot, and it's the Marquesa pumpkin parking space. He's taking the scrap bamboo and he's making biochar by carbonizing it. And this is a little massage booth that got built over the river because we do like to have fun in Bali. So what's new? What's next? This is it. I can't show it. It isn't published yet. But this is my last slide. And that's a really light bicycle. But I just encourage you to think about bamboo. It's time that India did something about bamboo. There's a whole lot of guys talking about it and talking about it and talking about it. But let's build bamboo. The only way you can do it is you take the bamboo and you build something. So, thank you very much.
Well, thank you very much, John, for a very fascinating and interesting presentation. Thank you very much. I think you have shown a number of very complicated structures, and I can tell you, in an earthquake zone, in normally reinforced cement concrete structure or steel structure, we want a symmetry in plan and elevation. But here, because this is the material is so good, it can undergo very large deflections. So you can create all sorts of forms like this. Unlike RCC structure, you know, one of the conferences, an architect said that I make building like this, the way you are showing. In RCC, you will spend huge money. Then all the green building concept is gone. But here, this material is so good. Now I'll come to the hard engineering side for this. I'll now give a presentation. So I think just give you an engineering side of the bamboo. That bamboo has a high strength to weight ratio and ease in working. You have seen how fast he has made with simple tools. It has a long and well-established tradition as a building material throughout the tropical and subtropical regions. You've seen Bali, how many interesting structures he has created. Now, it is used in many forms of construction, especially in housing rural areas. He has shown some of them. However, enough attention has not been paid, as he also mentioned, towards research and development in bamboo and construction material for different uses. Lightness makes bamboo suitable for housing in disaster-prone areas like prone to earthquake. As I said, earthquake is directly proportional to the mass, the weight of the structures. And these are very light structures. So they are very good for earthquake-prone zones. It has capacity to absorb more energy and show larger deflections before collapse, and as such is safer in earthquake. And one of the criteria when we design reinforced cement concrete structures, you will be surprised to know that the code has defined the maximum considered earthquake. We cannot design because an earthquake on 6.4 Richter scale is equivalent to the one atomic bomb which was dropped at Hiroshima. And at 7, it is such 10 some bombs. And 8.5, it is 2,500 such atomic bombs exploded together. So we cannot design. So what we depend very heavily that we depend on the ductility of structures. So we design actually only 10% of the maximum earthquake which can come. So here bamboo we can cater for because we in RCC, we think that the structure will undergo a lot of reflections, what is known as ductility before collapse. But it can go very large deflections, and you can create different forms. Now, at present, the application bamboo as engineering material is largely based on practical and engineering experience, since the design guidelines are very few and inadequate. In a circular cross-section, bamboo is generally hollow, and for structural purpose, this form is quite effective and advantageous. The strength of bamboo comes their straightness, lightness combined with hardness, range and size of hollowness make them potentially suitable for a variety of applications, both structural and non-structural. With good physical and mechanical properties, low shrinkage, and good average density, bamboo is well suited to replace both structural steel and reinforcing steel. More than 100 species of bamboo are available in India, and a few of them are solid, but most of them are hollow in structure. With decrease of moisture content, the strength of bamboo increases exponentially. You can see from this graph at 25%, it is the saturation point. You can see here, as in the beginning, as the moisture content, you can say this strength increase rapidly, but after that 25%, this is almost constant. Air seasoning of split or half round bamboo does not pose much problem, but care has to be taken to prevent fungal discoloration and decay. However, rapid drying in open sun and can control decay due to fungal and insect attack. A general observation has been that immature bamboo gets invariably deformed in cross section during seasoning, and thick-walled immature bamboo generally collapses. Now, these are some of the properties. These are our Indian Standard Code points out. It's very interesting that you can see that these are some of the types of bamboo. Maximum compressive strength varies from 36, 46, 45. This is as good as concrete. You know, for M20, the strength is 20 Newton, and this is bamboo has compression 36, 35. So it is a material which is very good, and density is light. You can see 620 kg per cubic meter, whereas concrete is 2,500. Modulus rupture is also very good. That means tensile strength is much better than concrete, 89 as against very small of concrete. So this has a lot of good properties. Then similarly, as per our code itself, the allowable bending stress is quite high. 20, 24, 16, this is as good for concrete. So for compression also and bending also, this is a good capacity. Now so far, as we have seen in presentation and we have seen in Northeast also, bamboo has mainly used for trusses and lightweight single-story sloped roofs, etc. But now, recently we have tried. I have tried in one project. The Zen Temple at Chennai. This is a very interesting story. When they wanted to make the Zen Temple, those who wanted to make this is for a builder society. There were a lot of people from Jain belief, and they wanted a Zen Temple. They said the primary requirement, no reinforcement, because it is not, as for religious beliefs, they do not want, because of meditation. So they asked me, what you will do? I said, the Lord, I said, the master will guide me. Whose temple is being made? No, we are making the temple. I said, no, you are making, but the one whose temple is being made, he will guide me. And finally, I got the idea, and you will see that we have made, how we have made with I can tell you a lot of even Akshardham. A raft was made without reinforcement. A lot of cracks were there because there was no reinforcement. Now we can take care by using bamboo. So in this project, as I said, we have used bamboo in pile cap, columns, and beams. Now you see how we are making a pile with the help of the bamboos. They are split. The bamboos are split. And what we did in the same complex, because a lot of towers were made, 20-story, 25-story. The same construction agency, Simplex, which was doing for reinforced concrete pile, we engaged them. And we guided them that you have to do like this. So they agreed. And we tested the piles. You will be all surprised, the capacity of the pile with reinforcement and the capacity of pile with bamboo was same. There was no difference. So these is the now pile being made with the cage being made with the bamboo. Even binders are made. You can see the photographs. So I happen to be there in the white cap. Now this is from the inside, you can see. This is finally in position. Now you can see that the cage is being lifted up. Lifted up, you can see the buildings behind them. And now they are being casted, concrete being casted. And this is the after casting, and then we wanted to test. So this one has to break the top concrete of the pile. We broke, but the bamboo will not disintegrate. You have to cut. Even once it is embedded, you have to cut. So then we tested for the load test, as I mentioned. And the load testing, the values were absolutely same what we got for RCC. So I think this is now a good beginning. And now you can see a lot of piles all around with bamboo projecting out. And even in the, so this is the cage. Unlike reinforcement which you see, this is the cage and the projecting bamboo. There are columns also, you can see. The column bars, instead of RCC reinforcement, these are all bamboo bars. You can see now the entire, with the complete pile cap, with the columns coming out. Just see. So even the beam, lintel beam, you can see this also with bamboo. Everything is bamboo. The columns are with bamboo. So I think now probably more and more research is to be required for using bamboo. As we have already done, we have tested. I hope that in future, he was telling somebody in Singapore, somebody is also doing when they are getting a lot of, but as a private consultant, we have to, on our own, we have to use it. And I think, I am very sure that with this new invention, this will help us in many ways with sustainable development. Thank you very much.